let us see an example on Deutz algorithm. I've considered a function f of x whose value is 1. There are two inputs and for both the inputs it is 1. So we are asked to apply Deutz algorithm and find the output for it. Okay. So how do we solve it? Let us see. Let us consider the initial state. Let the initial state be get xi in, I will say this is equal to 0, 0, 1. Now what I will do is I will apply Hadamard gate. Of course I should say gates. Okay. To this state. Okay. Now get xi prime is nothing but 1 by 2 root 2 0 0 minus 0 0 1 0 1 0 plus 1 0 0 minus 1 0 1 plus 1 1 0 minus triple 1. Okay. Now after applying Hadamard gate, we'll apply UF to it. Okay. So what I will get would be applying UF get xi prime. What I will get would be get xi double prime. This is equal to 1 by 2 root 2 UF. Applying UF, what I will get, that's what I will write. Okay. 0 0 1 minus 0, because the function value is 1 for all, guys. Hence accordingly I am applying UF and getting the value. Okay. Right. Next, the final step would be applying Hadamard gate twice to the first two qubits, to the first two qubits, and not applying anything, not applying anything to the third qubit. That is applying identity, I can say. Applying identity. Okay. So what happens is finally the output would be get xi out would be 1 by 2 root 2. Guys, I'll just mark it with a different color so that you understand. The first two, 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 and the first two. Two Hadamard gates on the first two. So accordingly, what I'll get, Hadamard gate on 0 0 twice would give me what? Get 0 plus get 1 by root 2 into get 0 plus get 1 by root 2. Okay. And then ket 1 is as it is. You understand, right? Yeah, there's a negative sign. You see, I'll write. Now you understood the rhythm, right? Ket 0 plus ket 1 by root 2, 2 times. Okay, of course, yeah. Ket 0 plus ket 1 by root 2, 2 times. And then ket 0. Okay, now next. Plus ket 0 plus ket 1 by root 2 once. Okay. Next it is ket 1. So ket 0 minus ket 1 by root 2. Hadamard gate of ket 1 and I am left with ket 0. You are understanding the rhythm, right? What I am talking about. I'll just move this here. Okay. So ket 1 and ket 0. So ket 0 minus ket 1 by root 2 of Hadamard gate, ket 0 plus ket 1 by root 2. Again by Hadamard gate, I am left with ket 1. Which term I am talking about? The fourth term. Okay, guys? Oh, no. They should not go up. Yeah. Minus ket h of ket 1 and h of ket 0. So I'll have what? Ket 0 plus ket, no, minus because it is 1 root 2 and then ket 0 plus ket 1 by root 2. Okay, what I am left with is ket 0 here for this term. Okay, there are two more, one with a positive sign and one with a negative sign. For both of them, it is ket 1 and ket 1, right? H of ket 1 and ket 1. One is ket 1 and the other one is ket 0. Okay. So I will be having ket 0 minus ket 1 by root 2 into ket 0 minus ket 1 by root 2 into ket 1 minus, this is also the same one, ket 0 minus ket 1 by root 2, ket 0 minus ket 1 by root 2, there is a ket 0 at the end. Okay. Finally, it is all about this. After applying what? Hadamard gate to the first two qubits. Of course, you can simplify this, guys, but very carefully taking care of the plus and the minus signs. I hope I have not made any syntax errors or mistakes. Kindly check them. I hope whatever I am trying to dive, the concept is fine. Now, by if I expand, finally the output would be, looking at it, you should write, guys. Of course, just see here, every term has 1 by root 2, so it becomes 2, guys. So this outer term would become 4 root 2. 1 by 4 root 2 it would be. Okay. 1 by 4 root 2. Right? So now see here, I will first combine the two ones and then finally mix it with the third one. Okay. So what will I get is 0, 0, 0, 1, 1, 0, because both are plus in the first one, 1, 1 in the first one. Okay. Yeah. This is accompanied with ket 1 minus 0, 0, 0, 1, 1, 1, 1, 1, 0 plus 1, 1 accompanied with the ket 0. All these are accompanied with a ket 0 and a negative sign. Okay. Plus, there are huge terms, guys. Okay. So, you have to write all of them very carefully. How many I have written? I have just written 2. Let me see how many are over. Okay, this is over and this is over. Now, coming to the third one. I'll have a ket 0 at the end for it. So, I'll have 0, 0 minus 0, 1 plus 1, 0 minus 1, 1. I hope it's clear now, right? With the ket 0. Next one for this term, just see 0, 0, 0, 1, 1, 0, 1, 1 multiplied by ket 1. Here I have ket 1. Next, there is a negative sign and the terms follow, guys. Okay, I will just finish it, of course. 1, 2, 3, 4. Okay, 1, 2, 3, 4 are over. So the fifth one would be 1, 0, 0, 0, 0, 1, minus 1, 0, minus 1, 1. Any corrections, do post them under the video, guys. Okay, accompanied with the ket 1. 0, 0, 0, 1, 1, 0, 1, 1 with a ket 0. Okay, plus 0, 0, 0, 1, 1, 0 plus 1, 1 with a ket 1 again, minus 0, 0, 0, 1, 1 0, because it is becoming so huge only, we have used some logic to write it, okay, in the derivation of Deutz algorithm, okay, but that's fine, whichever you are comfortable with. So finally it's enclosed with a big bracket for 1 by 4 by root 2, 4 root 2, 1 by 4 root 2, okay. So now if you want to factorize these terms to put them in the form within the third qubit as minus 1 minus no ket 0 minus ket 1 by root 2, if you factorize them and put them as one qubit wherever there are common terms, so something like this I will get. Common terms if you pick up 1 by 4 minus 0 0 0 1 plus 1 0 plus 1 1. If you want to put it like this, I'm talking about this version of writing. Another version, if you choose another way of writing it, okay. If you are choosing them in this version, then how would the output look like is what I'm talking about. Ket 0 minus ket 1 by root 2 minus 0 0 0 1 1 0 1 1. Okay, again this is accompanied with ket 0 minus ket 1 by root 2. Okay, yeah, minus 0 0, of course, 0 1 minus 1 0 minus 1 1 accompanied with ket 0 minus ket 1 by root 2. One more term is there, 0 0 0 1 1 0 1 1 accompanied by ket 0 minus ket 1 by root 2. Okay. Now finally, hence the output would be, just see what happens here. I have taken all these terms common. I'll just put a bigger bracket for 1 by 4 guys. 1 by root 2 I have taken inside, right? So finally my output would be something like ket out would be minus 0 0 of ket 0 minus ket 1 by root 2. Okay, now you see, actually he has asked in the question, I have written it, find the output, but then he has asked, generate